We will now set up the mapping lab. For that you need the line following course from the previous lab. You will need the line following lab, which was the epoch going around the line on the ground, like so, as well as the code, the line following controller. And in this lab we will add a LiDAR sensor. For this you have to open the epoch in the scene tree and then scroll down until you find the turn slot. And in the turn slot you can add children, including LiDAR sensors. So you type LiDAR in here and you see all the different LiDAR sensors that Webots is offering, like from Hokuyu, EBO, or from Webots, which we will use in this lab. And once it appears on the robot, you can see that it is actually facing forward. We can use it right away. Let's save. And what we need to do is we have to enable the LiDAR sensor. For that I want you to copy and paste its name. So you can have a new object in Python, robot get device, and now we use the LiDAR sensor name, and we have to enable this at time step speed. But what we also have to do is we have to say enable point cloud to put the LiDAR sensor in point cloud mode. Now if you do this, you can go to view and go to optional rendering and select show LiDAR point cloud as well as show LiDAR ray paths. And once you do that and you press play, you should see the point cloud sensor firing up and the robot driving around the circle. Now you will notice that the LiDAR sensors disappear once the robot gets too close. This is because the LiDAR has a minimum range, which is too low in this case, and the Webots sensor has a maximum range of 3.50 meters, which is plenty for this environment. But in order to really see this, let's add some obstacles. So make sure you move out of the turret in the scene tree, otherwise you will add obstacles to the turret window, which we don't want to do. And click somewhere inside the scene tree and add other obstacles. When you type breakfast, you get a couple of kitchen items like a biscuit box or a honey jar, and you can place those somewhere in the environment. You can also use copy and paste in the scene tree. That gets you a second honey jar. Let's add some other things like a biscuit box. And this one is too low for the LiDAR when it lies flat. We can visualize this by pressing saving and then pressing play. And you will now see the LiDAR rays are just going above the sensor, which is expected behavior. And also they go around the jars, which are actually becoming a little narrower at the bottom. So what we want to do is we want to pivot this biscuit box up by 90 degrees, and then we can lift it up. And now you can copy and paste it and place a couple of these in the environment. Maybe you want to rotate it a little bit. And here it doesn't really matter where you place those. I just want you to put a couple of objects so that you can get a meaningful map of the environment. So we need something else here. Let's go back to the breakfast aisle in the scene tree view and get a jam jar we place here, and maybe we can find another interesting object to place here. So in general you can find these things under objects. Well, there's only these. Let's type in kitchen and you will find additional kitchen components or utensils, and maybe we can put a carafe here into the corner. Let's make sure the robot can still go around the obstacles, and let's see what happens when you go around all of these objects to see that the sensor rays properly hit. And so they also work on glass, as you can see here. Although in practice this should increase the noise. And so the robot can go around all of our obstacles, and we should be able to create a nice map of the environment. As a last step, we want to add a display to our robot, which will allow you to draw things directly from Webots. For that, we go to the ePUG again, go to its children, and there we add a display node. And I suggest to use a resolution of 300 by 300 pixels, and this is also where we will draw the map. As you can see, the display is now showing up in the right hand corner of the environment, and once we reload the simulation, we will see a 300 by 300 display that you can now enable in your code by saying display equals robot get device and then use its name, which is display by default. Now we can use the display in our main loop and use commands like draw pixel and things like this to draw on it.